Okay, so today we're going to be looking at this really fascinating research paper
Oh, yeah.
about replicating OpenAI's O1 model.
Mm.
And, it's been making a lot of noise lately, this model, because of its crazy good math skills.
Oh, for sure.
Even like acing those hardcore math exams like the American Invitational Mathematics examination.
Right, right. The AM.
Yeah, exactly.
It's been quite a race to replicate it.
It is.
All these groups all over the place are saying they've done it.
Oh, yeah.
Like Open O1 and O1 Journey.
All right.
Lame O1.
Yeah, I've seen those names popping up.
Yeah, they're all over the place.
But this paper we're looking at from the Generative AI Research Lab, or GAIR,
Right.
they're kind of questioning, how transparent all these replications actually are.
Yeah, I mean, that's a good point. A lot of these claims are kind of vague. It's
Yeah.
hard to tell, did they actually succeed or...
Right. Are they being totally upfront about how they did it?
Exactly. And how do you even build on their work if you don't know what they did?
Totally. And so GIR, they decided to test out this shortcut that some folks are using.
Mm.
It's called knowledge distillation.
Mm-hmm.
Do you want to explain what that is?
Sure. So imagine like giving someone the answer key to a math textbook instead of making them actually work through the problems.
Yeah.
That's kind of what knowledge distillation is. Like you train a model on the outputs of a more powerful model. In this case, it's O1.
Right.
And instead of building it from the ground up, you're basically just saying, here, copy these answers.
So it's like learning by rote memorization.
Pretty much, yeah.
Okay. So it sounds like it could be effective, but maybe not the most, in-depth way to learn.
Yeah, that's the big debate, right? Like it's a shortcut and it seems to work, but is it really AI?
Right.
GIR's results were actually really good, though.
Oh, wow.
Their model actually did better than OpenAI's own O1 preview on the AM benchmark.
Oh, wow.
And they did it with way fewer samples.
That's impressive.
Yeah, just tens of thousands.
Wow. So, okay, but wouldn't that approach like create a model that's just a cheap knockoff of the original O1?
Yeah. It's possible, yeah. There's a risk of hitting what they call a ceiling effect, where the copycat model never actually gets better than the original.
Right. It's like trying to become a master chef by just following recipes. You'll never invent your own amazing dishes.
Exactly. And GIR is worried that this focus on shortcuts could actually hold back real innovation in AI.
Yeah, that makes sense. So what did GIR do differently then?
So before they even tried distillation, they were working on this method, they call it journey learning.
Journey learning.
Yeah, it's this really cool idea where the AI basically tries out different ways to solve a problem. Like it explores different paths and learns from its mistakes along the way.
Oh, so it's a more organic kind of learning process.
Yeah, it's more like how humans actually learn, right?
Trial and error.
Exactly. And so it encourages the AI to think for itself.
But I imagine that's super computationally expensive.
It is, yeah, which is partly why their distillation results were so surprising. Like even with the shortcut, they got amazing results.
Yeah. So they didn't just stop at comparing these two approaches. They wanted to see like how far this math-focused model could actually go.
Exactly.
So they pushed it beyond just, solving equations.
Mm-hmm.
What else did they test it on?
They gave it open-ended questions and even some safety challenges, and what they found was pretty shocking.
Really? Okay, I'm hooked. What happened?
So even though this model was mostly trained on math, it actually got better at answering general knowledge questions. And even crazier, it became less susceptible to, like, blindly agreeing with biased or misleading statements.
Oh, wow. So like it actually learned to think more critically because of math.
It seems that way, yeah.
That's wild.
Yeah.
Have you any specific examples of that?
Yeah, there's this one about electric bikes.
Oh, okay.
So they asked the model about like the safety of locking and charging an electric bike in a hallway.
Okay.
Before the math training, the model was just focused on like preventing theft. But after the math training, it actually stepped back and saw the bigger picture, like pointed out the fire hazard of charging in a hallway and even suggested like safer alternatives.
So it was more cautious because of the math training.
Yeah, like
Yeah.
It had developed this sense of risk assessment.
That's really interesting. So,
Yeah.
okay, if this shortcut can lead to such positive outcomes, like why is GIR sounding the alarm? What's this bitter lesson they're talking about?
Right. So that's a great question. And that's what we're going to explore in the next part of our deep dive.
Okay.
They're arguing that even though it works really well in the short term, over-relying on distillation could have some pretty serious downsides.
Okay, so let's dig into those concerns and see what GIR proposes as an alternative.
Sounds good. So we saw that knowledge distillation, it can get some really impressive results really fast.
Yeah.
But GIR is worried about what it could mean in the long run, like if everyone just focuses on this approach.
Right. Could it actually hurt AI innovation in the long term?
That's exactly their point.
Okay.
And they've actually proposed this framework they call the Technical Transparency Index, or TTI for short.
Well, yeah, we touched on that briefly before.
Yeah.
Can you remind us what the TTI is and how it actually works?
Sure. So basically, it's designed to measure how open and reproducible different AI projects are.
Okay. So it's like a report card for how transparent these projects are.
Exactly. It's not just about the results, but also about how they got those results.
Makes sense.
Yeah.
So how does it actually measure transparency? What's it looking for?
Okay. So there are four main dimensions they look at.
Okay.
The first one is data transparency.
Okay. So being upfront about where they got their data, how they chose it, and what they did to it before using it.
Right. All the pre-processing steps.
Yeah, that seems pretty important. I mean, you can't really build on someone's work if you don't even know what data they used.
Exactly. What's the point if you can't replicate it?
Totally. Okay, so what's the next dimension?
The next one is methodology transparency.
Okay, and that's about?
So that's all about explaining, exactly how they did it, what techniques they used.
So other researchers could theoretically reproduce their work.
Yeah, exactly. No more like secret sauce or vague explanations.
Right, everything needs to be out in the open.
Ideally, yes.
Okay, that makes sense. What's the third dimension?
The third one is evaluation transparency.
Okay.
So that's all about, being clear about the benchmarks they used, how they measured performance, and whether they compared everything fairly.
Right, so, they're not cherry-picking results or presenting things in a misleading way.
Exactly.
Gotcha.
Okay.
And what's the last dimension?
The fourth one focuses on open source resources.
Okay.
So that means making their data, the code, even the trained model, weights publicly available.
So anyone can access it and learn from it?
Yeah, it's about sharing their work so others can build on it.
So did GIR actually use this TTI to score different O1 replication projects?
They did, and it's really interesting to see the results.
Okay.
So their own work obviously scored very highly.
Right, because they developed the index.
Exactly. They were very transparent about everything.
Good for them.
Huh?
But what about other projects? Were there any, surprises?
There were some projects that scored really low, like Skywork 01 actually got a 0.
Wow, a 0.
Yeah. They basically gave no information about their methods or their data.
That's a little concerning.
Yeah, it is. How are you supposed to trust their results?
Right. Okay, what about some of the other ones we've talked about, like Llama 01 or KA Math? Where did they fall?
Those were kind of in the middle. They were transparent about some things, but not others. It was a mixed bag.
Okay, so GAR is really pushing for this, more open and collaborative approach to AI research.
Yeah, they're setting a high bar.
But why is transparency so important in this field, especially when we're talking about something as powerful as O1?
Well, for a few reasons.
Okay.
I mean, first of all, without transparency, it's really hard to know if the research is actually valid.
Right.
Like, we need to know how they got their results to be confident that they're real.
So it's about ensuring scientific rigor.
Exactly. And second, transparency is crucial for actually building on existing research. Like, if we don't know how someone did something, we can't learn from it.
Right, or improve on it.
Exactly, and that slows down progress.
Interesting. So a lack of transparency can actually hold back the entire field.
Yeah, that's right. And then there's the bigger picture, too.
What do you mean?
Like, when things are hidden, it can create this hype cycle where people get really excited about flashy results without really understanding the technology. And that can lead to, inflated expectations and even potentially harmful applications.
So transparency is also about safety and responsibility.
Exactly.
Okay, so let's go back to GIR's concerns about knowledge distillation.
Right.
They talk about this ceiling effect. Can you remind us what that is and why it's a problem?
Sure. So the ceiling effect basically means that models trained with distillation are limited by the model they're copying. Like, they can only be as good as the original.
So we might be missing out on even more groundbreaking AI if we just focus on copying.
Exactly. What other downsides did they point out?
Yeah. What else are they worried about?
Well, they're also concerned that this focus on distillation will lead to a generation of AI researchers who are really good at tweaking existing models.
Right.
But they might not know how to come up with truly new solutions.
So, we're creating AI technicians instead of AI inventors.
Yeah, that's a good way to put it.
That's a scary thought.
Yeah.
Are there any other potential downsides?
Yeah, they also pointed out that this could hurt the academic research environment.
In what way?
Like, there's so much pressure to publish quickly and get those exciting results
Yeah.
that it might overshadow, deeper, more fundamental research that could lead to real breakthroughs.
So it's about balancing short-term wins with long-term vision.
Exactly. But does GIR think we should just abandon knowledge distillation altogether?
That's a good question.
Not necessarily. They acknowledge that it's a useful tool,
Okay.
but they're advocating for a more balanced approach where it's used alongside more fundamental research.
So like having a diverse toolkit.
Exactly. And they also emphasize the need for, continuing to invest in advanced computing infrastructure.
Yeah, because even with distillation, you still need powerful tools to really explore new frontiers in AI.
Right. It's like saying you can learn to cook on a basic stovetop.
Right.
But imagine what you could do with a fully equipped professional kitchen.
That's a great analogy.
Yeah.
What about their concerns about AI education? Did they have any suggestions for that?
Yeah, they actually propose a pretty radical idea.
Oh, okay, I'm listening.
They think we need to redesign how we train AI researchers.
Okay.
Like the curriculum should focus on both practical application and a deep understanding of the theory behind it.
So not just teaching students how to use the tools, but also how they work and how to build better ones.
Exactly.
That makes a lot of sense. So it sounds like they're really advocating for this more holistic approach to AI research and education.
Yes, definitely.
But what about their own research? Where do they go from here in their quest to understand and replicate O1?
Yeah, so it seems like they're moving beyond just trying to get the same results as O1.
Okay.
And they're really trying to figure out how O1 actually reasons.
So not just what it can do, but how it does it.
Exactly, like getting under the hood and seeing the gears turning.
That's a much tougher challenge, especially since, the full O1 model is still a black box.
Right.
So how do they plan to crack it open?
Well, they've hinted at a few interesting directions.
Oh,
Remember journey learning?
yeah, the approach where the AI tries out different reasoning paths, like a tree search.
Exactly. And they think that journey learning could be the key to unlocking some of the secrets of how AI reasons and learns.
So instead of just focusing on the final answer, they're looking at the whole thought process.
Yeah, like studying the map instead of just blindly following the GPS.
Makes sense.
Hmm?
What else are they working on?
Another thing they're looking at is developing better ways to evaluate these models.
Okay.
Because even benchmarks like the AIME might not be challenging enough to really test O1 level reasoning.
So they need to find a bigger, badder racetrack.
Like something that involves more complex multi-step reasoning.
Okay.
Maybe even problems that require creativity and original thought.
Wow, that would be a real test of AI intelligence.
It would. And of
Yeah.
course, GIR is still pushing for more transparency in AI research.
Right.
They see it as crucial for collaboration, for scientific rigor, and for preventing, the dangers of an AI hype cycle.
Because if we have AI, that's powerful, but we
Yeah.
don't really understand how it works, that could be a recipe for disaster.
Exactly. Transparency helps us manage those risks responsibly.
And on that note, here's a final thought for our listeners to chew on.
Okay.
If O1's reasoning abilities can be copied so easily, even with these shortcuts, what does that say about the nature of intelligence itself?
That's a great question. Is true intelligence about the process of learning and understanding, or is it just about getting the right answer?
It's a question that's been around for centuries, and now with AI, it's more relevant than ever.
For sure. This research from GAIR gives us a really valuable framework for thinking about these complex issues and for making sure that we develop AI in a responsible and thoughtful way.
This has been a fascinating deep dive into the world of O1 replication and what it means for the future of AI.
Yeah, it really makes you think.
Huge thanks to GIR for their groundbreaking work and their commitment to transparency.
Absolutely. And thank you to our listeners for joining us on this journey. We hope you found it insightful and thought-provoking.